Hello guys, welcome back to my channel Gamma Die Gamma. So in one of my previous videos, I actually started proving one of the simpler identities of the trilogarithm function. And I said to myself, let's cover all the essential ones eventually, video by video. So we're going to prove another dilogarithm identity in this one, the inversion formula for the trilogarithm. So let's get started. Okay, so as an introduction, introductory lemma, I would just like to state that we're going to deal with trilogarithm functions in this video. So we denote those as Li sub 3 of z is equal to sum from k equals 1 to infinity of z to the k over k cubed. And in all the proofs that we're going to be concerned with, we're going to use the integral representation of these. So that's the integral from 0 to z of 0 to the argument basically of the dilogarithm of some variable x divided by the same variable x dx. And proving that this is equal to this is quite simple. All you do is you take the definition of the dilogarithm, the sum definition of the dilogarithm function, and when you interchange the sum and the integral, you're left with the sum from k equals 1 to infinity of z to the k over k cubed, which is indeed the trilogarithm of z. So this is actually the identity, the representation that we're going to work with. So just familiarize yourself with this guy. Okay, so now see you on a fresh page for the proof. Okay, so the identity we need to actually prove is the inversion formula for the trilogarithm. The trilogarithm of negative z minus the trilogarithm of negative 1 over z is nothing but negative pi squared over 6 times the natural log of z minus 1/6 of the natural log cubed of z. Okay, so now we're going to get started. Let's get started with the left hand side. So on the left hand side, I'm actually going to use the integral representation for both the trilogarithms. So we'll have a dilogarithm of x divided by x dx subtracted uh, integral from 0 to negative 1 over z dilogarithm of x divided by x dx. So noticing that the upper bound of the second integral is the reciprocal, we would like to make it into a normal quantity, not a reciprocal. So for that, we're going to make the substitution. Let x equal negative 1 over u. So we'll have a dx to be du over u squared. So write the first integral as it is. And for this guy, we have when x is 0, u shall have to be infinity. So I'm repeating, when x is 0, u will have to be infinity in order for everything to work out. And when x is negative 1 over z, u will have to be a positive z. And we'll have the dilogarithm of negative 1 over u x is negative 1 over u, and the dx is a du divided by u squared. Okay, so we have integral from 0 to negative z, dilogarithm of x over x dx. Now I'm going to use this negative to flip the order of integration over here. So we'll just have integral from z to infinity of the dilogarithm of negative 1 over u, and 1 u will cancel, u du. Fair enough. Now I would like to use certain identities for dilogarithm functions. So the inversion formula for the dilogarithm function is dilogarithm of negative z plus the dilogarithm of negative 1 over z is equal to minus half natural log squared of z minus pi squared over 6. So if we just separate this reciprocal term out, we have minus dilogarithm of negative z minus half natural log squared of z minus pi squared over z. And the thing is, we have a reciprocal term over here for this guy. So I'm just going to make that substitution in here. We have integral from 0 to negative z dilogarithm of x divided by x dx. So all these terms have a negative, this has a negative, so it will be an addition, integral from z to infinity, dilogarithm of, our variable was u, so negative u plus, because we factorize out the negative, half natural log squared of u minus pi squared over 6, everything is divided by u du. And by linearity I'm going to split these guys up, and I'm going to change the u to an x. It's a definite integral, we can change variables as long as the integrand remains the same, plus half integral from z to infinity natural log squared of x over x dx. I'll write it below, plus pi squared over 6 is a constant which can be taken out, integral from z to infinity of dx over x. Okay, okay, fair enough. Now what are we going to do? Well, now look at this integral. These two guys can be, merged up later, but there's a problem of this negative z on top. So let's change x to negative x, especially for this guy. So we'll have integral from 0 to z dilogarithm of negative x divided by negative x and a negative dx, like that, plus integral from z to infinity of dilogarithm of negative x over x dx. And we have, well, the antiderivative of this guy can be calculated. It's basically like a u squared du situation where u is natural log of x. It will be 1 over 2 times 1 over 3, which is 1 over 6 natural log cubed of x evaluated from z to infinity, plus we have pi squared over 6 times natural log of x evaluated from z to infinity. Now these negatives cancel out, and merging them, integral from 0 to z of a one function plus integral from z to infinity of another function of the same function actually is integral from 0 to infinity of the dilogarithm of negative x divided by x dx. Fair enough. Fair enough. Now let's evaluate this. So we'll have, for the infinity case, we'll have a limit as x goes to infinity of 1/6 natural log cubed of x minus 1/6 natural log cubed of z, and a similar thing for this pi squared over 6. So we'll have pi squared over 6 limit as x tends to infinity natural log of x minus pi squared over 6 times natural log of z. Okay, although these limit terms are divergent because natural log at infinity will blow up to infinity, so although these are divergent, but we still haven't looked at this integral. So I'm going to call this I naught. Our LHS is basically I naught plus these other terms. So let's look at I naught on a fresh page. See you there. So as we discussed, I naught just turned out to be integral from 0 to infinity of the dilogarithm of negative x divided by x dx. Now what I'm gonna do is, since this dilogarithm behaves badly at infinity, I'm gonna split this up from the integral from 0 to 1, the dilogarithm of negative x over x dx plus integral from 1 to infinity of the dilogarithm of negative x over x dx. And now what I'm gonna do for the next trick is I'm going to try to flip these upper and lower bounds. So I'm going to let y equal 1 over x. So we'll have integral from 0 to 1, dilogarithm of negative x divided by x dx plus 1 over 1 is 1, 1 over infinity is 0, dilogarithm of negative 1 over y divided by x is 1 over y, and dx is negative dy over y squared. Okay, so I'm going to use this negative to correct the order of integration. So we have integral from 0 to 1. The y's cancel out. We can change again the variable from y to an x. Because it's a definite integral. And finally we can club these guys together because they're over the common region of integration. Everything divided by x dx. And we can again use the inversion formula for the dilogarithm. So remember, the dilogarithm of negative z plus the dilogarithm of negative 1 over z was nothing but minus half natural log squared of z minus pi squared over 6. So now applying that to our I naught, we have integral from 0 to 1 of minus half natural log squared of x over x dx minus pi squared over 6 integral from 0 to 1 dx over x. So this, if you want to do u substitution or just simple anti-differentiation, is natural log cubed of x evaluated from 0 to 1 minus pi squared over 6 natural log of x evaluated from 0 to 1. So at 1, natural log of 1 will be 0. Same thing for this guy. So we have 1/6 times the limit as x tends to 0 of natural log cubed of x plus pi squared over 6 times the limit as x goes to 0 of natural log of x. That's basically our I naught. Now let's put I naught back into our left hand side, the collective left hand side. So on this page, as far as now, what I've done is just written the collective left hand side, and now we can make a substitution for I naught. So I naught, I believe, turned out to be negative. Well, my bad, not negative, but just positive. 1/6 is limit as x goes to 0 of, well, natural log cubed of x plus pi squared over 6 limit as x goes to 0 of natural log of x, and then all these other terms of 1/6 limit as x goes to infinity of natural log cubed of x plus pi squared over 6 limit as x goes to infinity of natural log of x minus pi squared over 6 natural log of z minus 1/6 natural log cubed of z. Now I'm going to do a nice trick over here of changing or making a substitution in the limits. So all for all these infinity limits, let well x be transformed to 1 over x. So all the other 0 limits are as it is. Uh, we'll have limit as, well, as x tends to infinity, 1 over x will go to 0. So x tends to 0. Natural log cubed of 1 over x, I'm going to write that as natural log of 1 over x times natural log of 1 over x times natural log of 1 over x. Basically, multiplied 3 times. Plus pi squared over 6 limit as x goes to 0 now because of this transformation rule. Natural log of 1 over x minus these other z terms. Now, natural log of 1 over x is negative natural log of x. That's just a standard logarithm property. And we'll have 3 of these, right? So negative natural log of x, the whole thing cubed, is going to be negative natural log cubed of x. So we can make those changes. We'll have a negative 1 over 6 limit as x goes to 0 natural log cubed of x plus pi squared over 6 limit as x goes to 0 natural log of x minus pi squared over 6 limit as x goes to 0 natural log of x minus pi squared over 6 natural log of z minus 1 over 6 natural log cubed of z. So notice this term cancels with this term cancels with this. So all we are left on the left hand side is nothing but negative pi squared over 6 times the natural log of z minus 1/6 natural log cubed of z. And what was the left hand side? It was the trilogarithm of negative z minus the trilogarithm of negative 1 over z is equal to minus pi squared over 6 times natural log of z minus 1 over 6 times natural log cubed of z. And that, my friends, is the inversion formula for the trilogarithm function. Very useful, very useful. I will probably do a question with this, involving the use of this in the future. But it's just an incredible, it's a fascinating result. I mean, the entire journey, all these divergences cancelling out elegantly was just nice. So I hope you enjoyed this video, guys, as much as I did, and learned a lot too. So as always, please like, share, and subscribe to my channel. Recommend me to your friends. Spread the word of Gamma Da Gamma in the math community. And in the meantime, stay home, stay safe, keep doing math. Stay tuned for more content. Uh, it will probably be some integrals or some trilogarithm stuff. But in any case, stay tuned and peace out. Signing off.